Welcome to the presentation on solving the number of islands using depth first search. So we will walk through the problem statement, approach, implementation, and the time and space complexity. So let's understand the problem statement. So in this problem, we are given a grid where 1 represents land and 0 represents water. So we need to determine how many separate islands exist in this grid. An island consisting of one or more ones that are connected horizontally or vertically. So the approach one considers is, see, we traverse the grid cell by cell. So whatever the 2D grid I've showed over there, we navigate it, we traverse it cell by cell. So when we encounter a land cell, that is the cell which has one, we initiate depth first search to visit all connected land cells. Okay, so we mark the connected land cells as visited by setting them to 0 to avoid revisiting the same island. The number of times DFS is initiated is the number of islands. So the main function is shown over here. There is the num islands is responsible for traversing the entire grid. It first checks if the grid is empty and returns 0 if no data is present. So we calculate the dimensions of the grid, that is the number of rows and columns. That is the rows equals to length of the grid. That is how many rows are there in the grid and how many rows are there in the columns are captured in the rows and columns variables. And the island count variable is initialized with 0. Okay, so as I said, first we traverse the grid. So for every element in the grid matrix, that is R comma C, so if it is 1, then we increase the island count by +1, and then we initiate DFS. Okay, so what is the DFS? We'll see in the coming slide, and return the island count. So it is simple, right? So it's like going to the cell. If it is 1, increase the island count and call the DFS function. So this is the helper function. So it is a recursive approach that explores all connected land cells starting from a given cell. So you can see this is a kind of out of boundary indices. Okay, if the cell is already visited, both. So if R is less than 0, R is less than rows, or C is less than 0, C is greater than or equal to columns, or if the grid element is 0, don't do anything, simply return. Okay, so if it is not, then there is an element 1, right? And so in that case, it has to be made it 1, made it 0 to make sure that the cell is visited. So this is the condition we mentioned, right? Now visit all the adjacent cells, up, down, left row. So how for a given C, you move up and bottom, that is R minus 1, R plus 1, and C minus 1, C plus 1. So we have to ensure that we visit left, right, top, bottom. We have to call the DFS function on it. Okay, so this ensures like this function then recursively visits all 4 adjacent cells and explores the entire connected region of the island. The time complexity is O of m cross n times n. So because we visit each cell in the grid, the space complexity is also same O of mn due to the recursion stack used in DFS, which can be as large as the grid if the grid is completely filled with land. So this approach efficiently solves the problem with acceptable complexity. Thank you.